Okay, so all right, so now if we come up here, so this right here is the resistance. And so resistance is basically defined as being at an angle of 0 degrees. So you could rewrite this 6.8 K at an angle of 0 degrees. And this is a capacitor, okay? And the capacitor is defined as being a minus J, or if you want to write it in polar form, is 3.6 K at an angle of minus 90. So this J is referring to minus 90 degrees there. Okay. I had to pick up the phone to hear you again. I think you said it correctly though. Minus J is minus 90 degrees. A positive J is positive 90 degrees. That's, yeah. Okay, that's what yeah. And that's true, and the positive J, of course, goes with an inductor. Okay, yep, you've got that. So, so the other issue then now is what we're doing is we're trying to calculate the we're trying to get the voltage drop here. Okay, so we want to find the voltage VR. And so when we do that, we do a voltage divider rule. Okay, and so the voltage divider rule is defined as being the voltage that we're looking for. Whoops. The voltage that we're looking for, which is VR, is equal to the impedance of that value, which is the resistance, times your voltage divided by the total impedance. And since these two are just in series, the total impedance is this plus this. Okay. So, oops, scrolled down way too far. All right, so now the VR, okay, so VR is equal to this here, which is 6.8 K at an angle of 0 degrees times E, which is 120 volts. And that was ohms, of course. 120 volts at an angle of 0 degrees divided by the 6.8 K at an angle of 0 degrees. Okay. Plus the, what was it, 3.8? Where did I write that down at? 3.6. Plus 3.6 K at an angle of 0 degree, or not 0, 90, minus 90. Hold on. Minus 90. Uh-huh. Well, the resistor is in phase with the current going through it. So the resistor itself has an angle of 0. All right. So the voltage and the current across the resistor is going to be based on the total angle. All right. And so yeah, so I'm just going to rewrite this whole thing, but in terms of I'm going to rewrite this 6.8K. Okay, ohms. That's the resistance term, and 120 volts. Okay. This is rectangular form. All right, so this is 6.8K minus J 3.6K. Okay, and then of course that's ohms there and ohms there. Okay, so this down here, this is the same equation that's above the blue line, but this is in rectangular form. Yeah. Yes, so this is rectangular. And this one up here is polar. All right. So now let's flip over to the Octave software. So here's my Octave software. Okay. And I'm going to punch this now in the calculator. No, I've got recording on. Yeah. And the other thing I want to point out to you is that you can download Octave and install it on your PC. It's a free software, and it's a little more friendly, I think, if you have it installed instead of using the online piece through the web browser. Yeah. Okay. Now, the other issue here, I mean, I guess issue may not be quite the same term, the correct term, but because these are all K's, I can do it one of two ways. I can do 6.8 e to the 3, which would be, you know, times the 120 volts divided by parentheses. Now, this is the rectangular form. Okay, so I'm putting this in rectangular. And Octave is always going to give me the answer in rectangular anyhow. Rectangular. Okay. And so then I'm putting in the 6.8 e to the 3 minus j times 3.6 e to the 3. Okay. And hit enter. And that gives me the answer in rectangular form. So this is the one, I guess, caveat of this software is it likes rectangular form. So if you want polar form, what we can do is, I like to, using these brackets, I can break it up into kind of two pieces in one shot. So I calculate the absolute value, which this is like the magnitude squared plus the magnitude squared and the square root. So the ABS just does that for me. ABS means absolute value. All right, so the absolute value is, we take the absolute value of the VR rectangular. And one thing nice about this software is, you know, I wrote out this name really long, this rectangular. And so if I just type like part of it and hit the tab key, if there's only one match, it'll fill it out for me. Okay, so it saves some typing there. All right, and then comma, the tab key, yes. Okay, and I don't know if the online version does that, but certainly the installed version will do that. So VR, see, if I just simply type VR, since that's the only thing in there that begins with a VR, it'll fill that out. That's how, boom, I was able to type that real quick because I didn't type it. Okay, and I'm going to adjust my window here so it'll all fit on one line. So VR underscore rectangular. And then the only problem here is when I calculate this angle, the angle is in radians. Okay, so this angle is radians. All right, so we need to convert that. So I'm going to convert that times 180 divided by pi, and that will make it, that then makes it there. So then the answer to that is 106 at an angle of 27.9 degrees. Okay. Now, that's not the number that you gave me. All right, so yeah, so this is 106 amps. Not, well, wait a minute. Oh no, this was a voltage. Okay, yeah, 106 volts. Okay. All right, so this is going to be 106 volts at an angle of 27.9 degrees. That's supposed to be a 9 there. It looks like I lost half of it. Okay. This is a 9. 27.9 degrees. So, yeah, so that is the answer. And, you know, so, and where's my Octave window? There it is. All right, so here is how I calculated that. So I took the VR rectangular. Now notice here I put 6.83 or 6.8 e to the 3 because it was 6.8k, right? So this e to the 3 means 1,000, 10 to the 3. And so I had to do that everywhere. Now, I could have, because they were all K's, I could have taken it out everywhere. And then when I calculated my answer, okay, now when I calculate this answer here, notice that the answer actually is the same because the K's end up canceling. All right, because you've got K's, you've got K in the numerator up here and K in the denominator, and they end up canceling out because it's a voltage divider. So that's why the answer turns out to be identical whether I put the e to the 3 in or not. All right, but that only works for voltage divider type things. But if it was for a current type thing, if I was just calculating the current and I left out the e to the 3, I have to remember that I'm going to end up with a minus e to the minus 3 if it was a current calculation. Okay. The I is the J. Okay, the mathematicians like to use an I to represent the imaginary portion or the square root of -1. So all your calculators, and no matter, whether it's this Octave Software or your TI-84, it uses an I to represent that square root of -1. But we like to use J because we use I for current, and it gets really confusing. Yes. Okay. Yeah. So yeah, it's going to, and that's the rectangular form, of course, and then you have to convert it. But okay. All right. So so that was a voltage divider example here with a simple series circuit, and that gave us the voltage across the resistor. Okay. So if we wanted to calculate then, say, the voltage across the capacitor. Okay. So let's just go ahead and do that while we're at it. So the voltage across the capacitor here. Okay. So the voltage across the capacitor the equation for that it really looks almost identical. The only difference is we have the impedance of the capacitor. Okay. And then we had E, and then we had underneath then a Z total. Okay. So Z total is the same as it was up above, which is the 6.8K minus J 3.6K. But now here we have to put the minus J 3.6K. And then, of course, our voltage hasn't changed. So it's still 120 volts at an angle of 0 degrees. All right. And, of course, there's the units here, I kind of didn't put in the units, but these are ohms, ohms, and ohms. Okay. All right. So it's annoying. All right. So the All right, so that's the only difference there. So if we flip back to Octave now, so if I flip back to Octave to calculate this, okay, and again, this is kind of a nice feature of Octave, is I can use the up arrow key, and I can come back up to the rectangular, and I just come over here and change this. This is my cap, okay, and the only thing that changes, okay, so the only thing changing here, let me get it both on the screen here if I can. Okay, so the only thing that changed is this piece right here. Okay, so when I recall that equation, all right, I recall the equation, I change it to cap here, and then I just change this one spot. So this is minus j times 3.6 e to the 3, and that gives me my voltage across the capacitor. Of course, that's in rectangular form. So now I'm going to recall this equation for the resistance, and I'm just going to change, it was VR, everywhere was VR, I'm just going to change it to capacitor, cap. Okay, so very quickly, boom, that gives me the voltage of the capacitor. And so I'm just going to paste that down in here so then I can draw on the angles and whatever. Okay. So, so this is the voltage. Okay. And it's a negative 62 degree angle. Right. So the answer. Okay. So the answer, this is a voltage. So that's volts at an angle of minus 62.1 degrees. Okay. So now, if we wanted, let's just go ahead and maybe this will help you understand the angle sum. All right. So this is the voltage of the capacitor. And this over here, if I can grab this, is the voltage across the resistor. Okay, so this bit was the voltage across the resistor. Okay, and so now let's draw let's draw a line here. Okay, so this line, I'm going to make it black. Okay. This line represents my source voltage, E, at an angle of 0 degrees, right? So this was, what was that, 100 volts, 120 volts, 120 volts, angle 0 degrees. Okay. And then the voltage across the resistor is 106 at an angle of positive 27 degrees. So let me just shift this a little bit here. Okay. All right. So this is E. And then the blue now, okay, I'm going to draw a line. I'm going to kind of try to make use of this software here. So I'm going to draw a line, okay, and this line right here, and I may be a little bit off here, but the one thing I found out about this software is I can give it an angle. So what I'm going to do is I'm going to kind of capture this. And I'm going to rotate this at an angle of 27.9 degrees. Okay. Oh, 27.9. It won't let me do that, so I'll just round up to 28. Okay, so there's my 28. Okay, so this then is my V polar. It's the software. The software that I'm using, for some reason, they have positives going clockwise. Yeah, that's why. Here, when I do the other one, you'll see. All right, so this one is about 56, so that's about half of it. Now, this isn't to scale. I'm just kind of doing this roughly. These aren't actually to scale in this case. But, yeah, so when I do this one, it's about 56 is about half. Okay, and then just put my little arrowheads there. But all right, so yeah, so see, when I take this, when I select the rotate, oh, yeah, see, it was selected clockwise. So when I put in the angle, it was going clockwise, which was kind of backwards. I guess if I would have selected this counterclockwise and then say minus 62, you see the arrows pointing down. But if I select this, it points it up. So that's why it depends on which, it's just a software setting. But anyhow, so then when we take that, you see if these were actually to scale, they should end back up at E, right? So that's Kirchoff's voltage law. Oops. All right, so then this guy over here is V cap, all right, which was a 56.1 volts at an angle of minus 62.1 degrees. So that angle, so this angle here, I can't draw a straight line, but all right, so this is that angle minus 62 right here. Okay, and then the angle of 27.9 is right here. Yes, yeah, so we're going, the VR is going up in this direction, and the VC is coming back down. It's a negative direction, so it's coming back down. Okay. Yeah. All right. And, you know, we can also do that over here. I can take VR rectangular plus V cap rectangular, and I add these two together, and I'm back to 120 volts. And see, this is like e to the minus 15 here, so this is basically 0. All right, so if we look at that, if I dump it in this software, then I can scribble on it. All right, so here, this is doing it mathematically in Octave. All right, so if we look at this, right, this turns out to be 120. So it's 120, and then this value is basically 0. All right, so this is 120 volts, and then this is basically 0. Okay, so we're at 120 and an angle of 0 degrees, which is, of course, what E was.